So today we're going to be boring a set of cases using one of our sets of 4 1/8 bore. So these are for the 4 1/8 bore, and it's going to be on a 4 3/8 stroke for Andy, one of our channel subscribers, and we're doing a 117. So I'm actually pretty happy to have these new cylinders, and let me show them to you here. These, of course, they haven't been bored and honed yet. These are the rough cuts, but you know, it's got a really thick, as you can see, a real thick cylinder liner there, and these are awesome. You can tell it's a real heavy casting too, so it's pretty good stuff. Excited about that. So I had to wait to do any machining on these cases because I wanted to verify the diameter of the spigot here. The stock twin cam cylinders, the spigot here only extends 1 inch, and this is 1.5 inches, so these settle quite a bit deeper into the case, and it's you know, it's a real rigid setup when you're running that much stroke. The other thing this allows us to do, one of the reasons our twin cam, you know, large bore engines like this last so long, is I design all the pistons to have a ridiculously long piston skirt. And sometimes, yeah, it does mean the skirt will protrude a little bit below the bottom of the cylinder, but that's okay. It's not a big deal as long as it's not too much. But what that does for it gives you better piston stability, better ring seal over time, and all that type of stuff. So that's the reason this looks. I'm going to be looks like it does, and as long as it is. I'm going to be moving the camera several times, and I thought you guys would get a kick out of just kind of seeing the operation of this. So I'm going to start with measuring the cylinder, and then I've kind of already set the case up on the mill, but I'm going to give you an overview of the setup and let you see, because, you know, this is a set of VIN numbered cases. You got one shot to do it right. And because of the size that we're going, you know, you've got bolts that go through the case, you've got ports for the piston oiler, you know, you got all that stuff going on in there, and you've only got one shot to get it right. Another operation, I don't know if we're going to have time to do it today, but this particular case had 2 studs in it as well that had started to strip. So that's probably something I can show you guys how to do. We basically use a time-sert, not a Healy coil. And it's a little more complicated operation, I guess. It's not that big of a deal, but to use a time-sert than it is a Healy coil, it's not quite as easy. But it is definitely much better. And anytime we do ProCharger engines, big engines, stuff like that, we always time-sert all the holes for the cylinder anyway, because it's just a lot more rigid format in there. So give me a second. Let me move the camera here, get some things plugged up, and then we'll get started. So as I said, this is considerably larger than a twin cam. And one thing I like to do, there's a lot of these off the shelf and then boring with different fixtures, and you throw these things together, you end up with a lot more clearance. People tend to build in more clearance between this and the case just because you have core shift between the cylinders and core shift between the case and such. I don't like doing it that way. I actually like to fit this tight enough that I have enough clearance when that sleeve heats up that it's not become an interference fit, but I want to be able to support this sleeve with the case. So I run a very tight tolerance between measurement between the skirt here, the sleeve, the spigot, and the case. So I always measure it. I mean, we could be a thou or two off, and thou or two is pretty close. All right, the other thing I want to measure is my depth. And, you know, this is an important measurement. It's not, I'm going to say it's not extremely critical because you can be off by several thousandths. And, you know, normally if I'm doing ultra precise type measurements, I'm going to use my surface plate. But in this, there's no need for me to use a surface plate. Zero that bad boy out. And I know where we're supposed to be, but we're going to check it just to make sure. So as with anything in a fixture, you can always have movement this way and this way. So one way, you can use a dial test indicator in here and check, make sure, you know, we're level that way. Then you have to set it up to where you're dead center of the hole this way and this way. And what's amazing is when you're setting these up, you start to realize how much core shift you actually have in the stock cases. You know, you're setting up a precision piece of equipment here, and comparing it to that, those holes actually move around all over the place. But one way that I set mine up is this little fixture right here is pretty nifty. So it's running 2 indicators on it. Each one of these are in half thousandths increments, and that goes up inside the quill of the mill, and that allows you, and then you zero these in, and that allows you to tilt the case back and forth, and you just watch the indicators until they're perfect with each other. So for me, I'm wanting to get it on 0, measuring with a half a thou dial indicator. So we've got a digital readout there, and I always like to use a digital readout even though it's stationary, because with every machine you're going to get a little bit of movement, and this is down to 1/10 of a thou. So you're going to get a little bit of movement, and this is a tough process. Things move. It's a big hole. So I always watch my DRO over here. That way, if the case moves any at all, I can keep track of it and then move, recenter, and keep going. So one thing that I need to do is zero out my depth. I had not done that yet. Looking at it as doing it in reverse. So what I've done here is zeroed out the cutter on this stop. So I know that if this head is all the way down and here, I'm basically at 0 with the top of the deck. But we measured our spigot, it's an inch 500 thousandths. I'm going to add about another 30 thousandths to that depth to give us some room for expansion. So the easiest way to do this, I know where that's at. So then what I'm going to do is now raise the table, Z-axis. I'm going to raise it up 1 inch 530 thousandths, and then I know when I'm bottomed out here, that's going to be my final depth. The other thing is that particular cylinder, I'd have that cylinder made so that it's actually 20 thousandths shorter than a stock cylinder, so that I can then run a 20 thousandths base gasket on it. So the clearance that I've built in here on the bottom at 1 inch 530, I'm actually going to have 1 inch 550 50 thousandths because that cylinder is going to move up 20 thousandths of an inch. That gives me plenty of room for everything to grow like it needs to. You got to worry about tool chatter as well. So a lot of times what happens, I'll set the machine up to that particular speed that's ideal, and if I'm getting tool chatter, if it doesn't sound just right, then I'm going to dial that in to deal with the chatter so I get a smoother cut. The other challenge with doing this stuff is you're not boring a regular hole. You have cutouts inside of here in notches. So what you're going to hear, the cutter, you're going to hear it going tuck, 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 tuck as it goes around, and it's hitting those cutouts that are down inside there. All right, so a lot of this is experience and not really science, but we're going to play with the numbers anyway. So what we have is calculator, 250 surface feet per minute times 4. Of course, that gives us 1,000. We're going to divide that by 4.3. Let's see, 4.308, and that's going to give us 232 RPM. All right, so we got our depth set, and I'm still centered. All right, you can see the counter bore right here, this ring that goes around it right there. All right, so give you a perspective, we're actually boring just a little larger than that OD, that counter bore that you saw. Perfect. That's what we were after, and we've got no rock at all in the cylinder. That's ideal. That's what we're after. All right, let me give you guys a peek and see what we've actually got here. Now, remember, this is a setting fixture, and this setting fixture is supposed to be perfect and lined up with the case. But what you're going to see is we're Let's see, 35, 30, 37, 47. We're about 10 thousandths off on the case. All right. Now remember this. Remember this gauge is to a tenth of a thousandth. All right. See, so they should basically both needles should be in the exact same space, exact same spot. Since they're not, we know the case is tilted one way or the other. So that's the reason we take the time to, we take the time to check this stuff. Can't, tooling, things are, you have tolerances with everything. All right, so as you're boring, let's see if I can get in here. You see this area right here, right? So where my finger is right there, this area is getting incredibly thin. But what I do is actually, spot face this side over here. And then for this side, because it's a very large bolt that goes through, we make a bushing that goes into center a 6mm grade 8 bolt that goes all the way through the case. And then we, again, we'll spot face this side right here. All right, you'll see here what we've done. If you guys remember this piece that was sticking up here, we milled that off because we were, talking about this piece right here breaking. So we milled this piece off, leaving this behind. So all I'm doing now is hand filing away all the sharp edges to finish this off. Beautiful. All right, see what we did there? Open that gap up. Now let's slide the, I don't know if y'all saw the picture on the community tab. I went ahead and made another 6 or 8 of these just so I have them. So our test fit, we take our bushing, slide it in right there, slide our screw all the way through, and then you see on that side, stick out of the screw right there. It's a perfect length for us to put a sealing washer on it, and then a small nut. And everybody see that? All right, now the bolt will pass all the way through, hold that sucker together nice and tight between the cylinders, and you're a heck of a lot less likely to get any type of base gasket leaks. All right, so I'll compare this. All of this will make sense as to the reason why we do this bushing with the bolt thing, because I didn't explain that. This is the standard case bolt that would go through here. All right, and as you know, we cut a lot out of this cylinder. So if this bolt were in there, actually I can show you. If this bolt were in there, see where it's at right there? This bolt, where it comes through, would hit the cylinder spigot. All right, so that's why we have to clearance this out. All right, now this would not be big enough for this bore size for our 4 1/8 bore cylinder, but this is what they use on like the 120Rs, or if you go to your Harley dealer and they do, the 120 conversion on the twin cams, and you can see how few threads you have here, and you saw how thin this material is here after you bore it out, right? This is the bolt they want you to use, and what you would normally do is run this bolt in and just thread inside the case deeper. But if you look right here, how little material from the end of this bolt to here, there's not, that leaves you with only about that much thread holding the top of the case together. And that doesn't, let's just say that doesn't get me very excited. But anyway, all right, so let's drop the cylinders on and I'll show you guys how precise of a fit these are. I think you can see. That's only 5/1000ths per side because I want the case to support the cylinder spigot. Perfect. And then if we look on the inside here, all right, see where that bolt is. What would happen if that bolt wasn't large enough or was too large, it would contact the cylinder and then crack it. Beautiful. All right, and that's it, case boring. The other thing is the cylinder and the case deck being perfectly flat. I had machined those. I did that off camera, put the case together and decked it. So if I put my hand on here with no studs in it, notice that cylinder is perfectly flat. A lot of times what will happen is if you don't take that extra step to do that and you rely on the base gasket to seal this, again, you end up with base gasket leaks. So we've got a perfect fit in there with no rock. Y'all have a great night, guys. Take care of yourselves and each other. Have a good one.